Thank you very much, Janine, and thank you also to Zane. We've done quite a few months of road shows along the way on the subject. So, and I've really enjoyed it all because each time we've had challenging and different questions from the audience. So it keeps me on my toes and it keeps me thinking a little bit. So Janine approached me a while back to ask me to talk about plastics and plastics in medical devices as a result of a publication that we'd published that caused quite a stir regarding the phthalates in cling wrap. So I happened to get a letter from the plastics industry telling me that I'm going to ruin the plastics industry and cost 250,000 people their jobs. I said it's not the case. I think you just need to start looking at alternatives because there are. So tonight I'm talking a little bit about treating patients with tomorrow in mind, endocrine disruptors. And that's just a general disclaimer that we put in from the university side. But my presentation overview is going to include the introduction, where did it all start, something about endocrine disruption, then EDCs in the healthcare space, and conclusions. But as Janine knows, I like to talk and I digress and then I come back because I sometimes think of an interesting fact to perhaps add. So if there's something, you're welcome to also stop me along the way and ask. So people are exposed today to a multiple of potentially hazardous environmental contaminants as part of our daily life. And these, some of these contaminants are called endocrine disrupting chemicals. And there are a number of human biomonitoring studies that have detected EDCs in almost every individual analyzed, and in a variety of fluids as well. So we're talking about placental tissue, breast milk, urine, blood, and saliva. So when did it all start? There was a lady by the name of Rachel Carson. She was a scientist as well. As far back as 1962, she wrote a publication called The Silent Spring. And she described then already how DDT could enter the food chain and accumulate in the fatty tissue of animals and humans, because DDT, the chemical, is lipophilic, so it's going to go and sit in the fat tissue. And it caused cancer and genetic damage. But we also know the other effects in wildlife is egg shell thinning, killing of the birds, and of course it was used in those days not only for malaria vector control but also agricultural purposes. Today we only use DDT for malaria vector control and not for agriculture. However, we do find it on the black market here in South Africa, in places where we would think you wouldn't find it. And a single application of this would kill not only the crop, but also the insects targeting the crops, but also anything else as well. And the problem about DDT, it remains toxic in the environment for weeks and months, and its breakdown product, DDE, can stay in the environment for up to 60 years. So it is not a very good chemical. And one of the legacies that Silent Spring sort of gave us is that it brought about a new public awareness that nature was vulnerable to human intervention. And conservation never raises broad public interest unless it directly affects you. And there were very few people concerned about the disappearance of wilderness and wildlife in the wilderness. I think we're perhaps a little bit more conscious today than they were many years, those years ago. I shouldn't say many years ago, that sounds like it was my grandmother, but it wasn't, it was more my parents' age. And then the threats that Carson outlined was that there was contamination in the food chain, cancer, genetic damage, deaths of entire species were too frightening to ignore because this was the reality of it. And there became a need to regulate the industry in order to protect the environment. And that was when we coined the term environmentalism, and it was born through this. And the hallmark of the second industrial revolution and the green revolution was the production and release of synthetic chemicals into the environment, the development of plastics and those sort of things. And there was emerging links to exposures to these environmental chemicals on the developmental and reproductive abnormalities in wildlife species. Why? Because reproductive endpoints are actually a relatively easy endpoint to measure. And that is where we started seeing it first. Male fish started producing the female hormone vitellogenin in response to chemicals that mimicked estrogen. So that was starting to show up in the wild. Then they went on and they did lab studies, and then they started seeing that these compounds had similar effects in lab studies using fish, rats, models, and also pig models. So it sort of became quite a hot topic at that time, and this mounting evidence suggested that the hormonal activity of these chemicals was detrimental, and it led to the endocrine hypothesis at a conference that was held in 1991 in Wisconsin, in the USA. And the scientists there coined the term endocrine disruptor. And they proposed that the developmental alterations that they were seeing in the diverse wildlife species were as a result of exposure to these chemicals. And they worked through different modes of action, and they disrupted the system, the endocrine systems of metazoan organisms. So in 1998, the US EPA put together a committee called the Endocrine Disruptor Screening and Testing Advisory Committee, because they wanted to develop this a way that we could start testing for these chemicals and what kind of actions these chemicals were causing. And they came up with a definition of what does an endocrine disruptor do and what is an endocrine disruptor. So they decided that an endocrine disruptor is an exogenous substance or mixture, and I want to almost underline mixture, that alters the function in the endocrine system and causes adverse effects at the level of the organism, its progeny, and populations or subpopulations of organisms. So that's first and second generation and further down. And this was based on scientific principles, data, weight of evidence, and as Janine spoke about, the precautionary principle, which I think is a very important term and concept to be aware of when it comes to these kinds of chemicals. So just, I know we've got a lot of medical people here tonight, but just briefly for those that aren't, just so that we can, you know what I'm talking about. We're talking about the hormone system. They consist of ductless glands that secrete hormones into the blood, and these hormones are circulated to all parts of the body and act on target organs that regulate our body functions. And they consist of the pituitary gland, the thyroid gland, parathyroid gland, adrenal glands, islets of Langerhans, gonads, testes and ovaries, and then also other organs that produce secondary endocrine functions. So hormones are quite specific. They bind to receptors, either nuclear or membrane, and produce effects. So the steroid hormones and thyroid hormones bind to your nuclear receptors, and your protein and amine hormones, the membrane receptors. And different types of cells express different combinations of hormone receptors. And the receptor for a specific hormone might be predominantly in one cell type, but it can also be found in another cell type throughout the body. And some hormones can bind to more than one receptor. And the same receptor may have different effects in the cells then. And some hormones only work through specific and at specific times during development and adulthood, because their receptors are only expressed at those times. So it becomes quite a complex system that one is dealing with. So, as I've mentioned, it affects, they affect and control the growth and developmental processes. our metabolic rates, our development and functioning of our reproductive organs, sexual characteristics and libido, a development of personality and higher nervous functions, and the ability of the body to meet conditions of stress, and immune system, and also resistance to disease. So when it was, as I said, it was focused in the beginning very much on the reproductive system, and a great stir was caused around the world because young men were starting to present with bad semen quality and increased genital malformations. And there was also a global increase of endocrine-related cancers, in the men, testicular and prostate cancer, even breast cancer in men, breast cancer obviously in women, ovarian cancer, and thyroid cancers. And then we started seeing also neurodevelopmental effects associated with exposures to these chemicals. And this was increased incidence of attention deficit disorder, decreased IQs, those sort of effects. And today they're even looking at autism as an association with exposures. And then they discovered that some of these chemicals were involved in causing obesity and type 2 diabetes, specifically also the insulin resistance diabetes. And that goes together with polycystic ovary syndrome, the metabolic syndrome. And I'll talk a bit more about that later. And yes, as I said, it's very difficult to make a direct link, but strong associations and odds ratios started being associated with all these various endpoints. So how are we exposed? Because we are sitting in a pool of endocrine disruptors actually every day. So we are exposed through diet. Just for interest's sake, 75% of our beef comes from feedlots here in South Africa. They are given growth hormones. There's a certain period to clear the beef before it's processed. But what happens to those hormones? They are excreted through the urine into the environment, which then has an effect on the local aquatic environment. And we all need to have healthy rivers because a lot of our communities are dependent on those rivers for water, to drink, to wash, to bath. So they are exposed through that pathway. Dairy products, fish products, also anything that's sort of like an oily fish, like your salmon and tuna. If it's farmed, you need to be aware of what the farming practices are and what the fish are being exposed to there. And then what they started calling emerging contaminants of concern were the pharmaceutical products. Something like your ibuprofens, diclofenac, acetaminophen. It's always such a long word. I should just say Panado. The GP's medication of choice. That should not actually be administered to your pregnant females in the first trimester. It happens to be an estrogen, and your first trimester is quite a critical period of development, and if you drink excessive acetaminophen at that point, you can have an influence on the fetus. Water, obviously our drinking water, we're fortunate here in Johannesburg and Pretoria. You might not think so, you've got Rand water. I can tell you very definitely that you can probably drink, well, I can tell you definitely that the water out of the tap here is just as good, if not better, than water out of a plastic bottle. And I can say that with safety because I had a PhD student that investigated that. And we looked at Cape Town water. The reason we did that was because there's different kinds of exposures. So up here we're looking more at industrial type of exposures of your flame retardants and those sort of plasticizers, few agricultural pesticides, but also pharmaceuticals, and then down in the Cape was more agricultural. And they also had different water treatment plants. Our water treatment plants here, I'm happy to say, use activated carbon. So that's very good for taking out, particularly the phthalates out of the water. For our experiments that we do in our labs, we have a special filter that we actually put on the end of our water purification system, because the water coming out of that is still not pure enough for our assays, because they are very, very sensitive. I would not drink the water in Witbank, for example, and I will not eat fish or water coming out of the Vaal Dam area. However, having said that, Rand Water's water comes out of the Vaal catchment area, but their processing is such that it is good enough and it takes most of the stuff out. So it's good water. And then aquatic sports. So yes, you don't want to water ski or swim really in the Vaal Dam or Hartbeespoort. Redflay Dam has also been shown that in a study that we did, that if you are watering your vegetables or swimming in the dam, you have a greater chance of developing and being exposed to these chemicals and developing cancers. But the good news is it goes through the treatment plant and is highly drinkable after that. Then we look at air for inhalation pollution. Janine spoke about dioxins and furans. That's how we are exposed to that. And just an interesting sidebar, when I started doing my experiments for my PhD, I was doing a cell culture assay looking at estrogenic activity. And I had to get a blank, a negative control blank. And one day it would work, and then the next time it wouldn't work, and then it would work, and then it wouldn't work. And eventually I realized the local microbiology lab, because my lab was in the Institute of Pathology, which had the micro lab, the chemical pathology lab, the hematology lab. They had an incinerator behind the building where they were disposing of the microbiological plates. And every time I had contamination, they'd incinerated some plates. So it was literally coming in through my air conditioning system. Didn't matter that I was working in a type 2 biohazard cabinet, it contaminated my cells. So that was also a process that we had to go through to also find out about a filter that we could put on the end. So, and then skin and dermal contact. We all like to use cosmetics, nice creams. Check that the creams don't contain parabens. They are not good for you. And also petroleum jelly. We like to smear our babies' bottoms with petroleum jelly. Most plastics are petroleum based, and petroleum itself is an endocrine disruptor, so we just want to be a little bit more thoughtful. It's also been shown that lavender oil and tea tree oil has caused gynecomastia in baby boys. So you also want to be a little bit careful when... Sorry? Yeah, it would be a petroleum-based product, yeah. So now I've told you a little bit about some of the products, but here we have groups of EDCs. Let's start with the natural EDCs. Phytoestrogen. Who likes to drink stuff like barley green? Anyone here? It tastes awful. I don't know how cows can eat grass because it really is awful. And barley green tastes just like leaves. Not even spinach, which is much better tasting. But that is a phytoestrogen. Soy is also quite a strong phytoestrogen, especially when you combine it with other xenoestrogens or estrogenic compounds. It kind of super estrogenizes. Then you get synthetics, the industrial solvents and lubricants, PCBs, biphenols, and dioxins. And that also includes our motor oils and things like that. We actually did a study looking at runoff water on a Friday afternoon in Pretoria West. That's a highly industrial area. There's lots of car servicing centres, tyre places, lots of fish and chip shops, and those sort of things. And you'll be surprised and quite horrified at what was going down into the water system from those factories or places on a Friday afternoon when they washed the floors. And then pesticides, pyrethroids, organochlorines. You often hear about glyphosate. Glyphosate's been shown now to be an EDC. And of course the organochlorines, which is your DDT, they use that for malaria vector control. And then that's in the more traditional hut. The more modern huts, which are made of bricks and normal roofing or corrugated iron roofing, they spray with pyrethroids. They have shorter half-lives, but they also are known to be estrogens on exposure. And then fungicides as well, and then I've mentioned pharmaceutical agents. I'm sure we all know the diethylbestrol story, and we're still seeing transgenerational effects of that exposure today still. In things like metabolic syndrome, also cancers in the uterus and cervix. So, and then diclofenac is also one that's a bit of a nasty, and we find it often quite a lot in our water and also at quite high levels. And then tonight we're concentrating, of course, on our plastics and plasticizers. Now we're all aware the bottles and the whole big production about BPA, bisphenol A. And every bottle's got a label on it that says this bottle of this plastic item is BPA free. It's not necessarily phthalate free, sorry. And they now need to start saying this bottle is BPA and phthalate free, and the rest of the BPs from B to Z, because they've replaced BPA with S and F. Sounds like I'm swearing, but they've had to use more of that compound to do the function of BPA, but they're not testing for it, and there's no legislation for it. But BPA, the minute there was any noise about the effects of BPA, Canada was the first country in the world to ban BPA across the board in the use of their products. They took that precautionary principle straight to heart, and they just said, no, not in our goods. Then we have a little chemical here that we call non-alphenol. Now that's a plasticizer. It's a nasty thing. It creeps. It's colloidal and it creeps. And that was one of the first things that was found to cause feminization in fish, in trout in the streams in Britain. And that was how they picked up on this thing that these products or these compounds are estrogenic. So we in our lab had a look and saw, we wanted to see what are South Africa's sort of levels. Well, we were horrified because our drinking water at that time, and I'm talking, we started doing EDC research back in about, it was about 99, 2000. And non-alphenol was actually the first chemical that we looked at. Non-alphenol itself is an estrogen. It's a Sertoli cell toxicant, so it immediately has an effect on the testes. But it as I said, it feminized the fish, and it was used in high concentrations in those days in cling wrap. We all have a roll of cling wrap in our kitchens. You get cling wrap and you get cling wrap. Please, if you're going to use cling wrap, use the cancer-approved cling wrap. We have double tested for phthalates. In those days, we tested it for non-alphenol. It had the lowest levels of non-alphenol. And actually, what we did was we used my boss at the time as a human guinea pig. And what we did was we took a hamburger, we cooked the beef, wrapped it in cling wrap, took the bun, wrapped it in cling wrap, had the Coke, had the milk, had the chips, everything. We put it all together in cling wrap, and we left it in the fridge overnight. Then the next morning, we heated up this dreadful concoction for the poor man, and we took his urine and blood as a baseline value. He had baseline values of non-alphenol. But after eating the hamburger and the cool drink and everything, fortunately, he didn't need a bucket after that, but his nonylphenol peaked within 2 hours of consuming that burger, and it stayed level for about 3 hours after that before dropping. Now, if you think of your chronic exposure every day to that, if you are exposing yourself to that, it can become quite considerable. The other thing about nonylphenol is it's a carrier molecule for pesticides. So the minute you want to carry anything over a membrane or into plants, they combine nonylphenol in with the pesticide so that it can then move across into the plants and into the insects. We actually have a colleague of mine at plant pathology at the university looked at the uptake of nonylphenol in plants from exposing it to plants, and there was definite uptake of nonylphenol in quite high concentrations into the plants. So we need to be aware that you can't use, they talk about recycling and spraying sludge onto agricultural crops. We need to really look at that and see if it's going to be a feasible thing to do. And then, of course, the big, dirty, I can't say doesn't because that belongs to the organochlorines, but the phthalates also are everywhere, people. I can tell you the chair that you're sitting on is containing phthalates. You are just ubiquitously exposed to it. And they are, because they come out of the plastic very easily, they make your possibility of being exposed to them quite easy. So let me put my glasses on, then I can read what I put in a new picture here of exactly what you'll find in a bottle. So you'll find BPA and phthalates and PVC in a lot of the bottles. And that is why the numbers are quite important. This was a recent article from Time. Even BPA-free plastics leach, EDCs. And if a product says it's free of that chemical, it doesn't necessarily mean it is, because you get non-intentionally added substances landing up in that product during the manufacturing process. But I'll tell you a little bit more about that just now. So how do these EDCs work? You get them that they mimic the natural hormone and bind to the receptor and give a similar reaction to a natural hormone. We call those agonists. Or they block the receptor and prevent the action of the natural hormone, and they are antagonistic. And then they can also affect the synthesis and transport and metabolism and excretion of hormones in a non-receptor mediated way. So the tests I have in my lab test receptor mediation. We do animal studies to also look at non-receptor mediated effects in our studies, and also in our men up north. So just to give you an example of how this actually works, my favorite chemical is, it's a good example. Bisphenol A, we know it's a plasticizer. It acts like an estrogen, and it goes into that receptor and it does what it needs to do, and it works perfectly as an agonist, and we'll call it an estrogen. But what if it binds to an androgen receptor? Because it can, and it blocks the receptor, and it has an antagonistic reaction. So here you've got one chemical that's got two actions in the body. And if you've got something like an estrogen and an anti-androgen, you're getting almost a super feminization. So, and this is the complexity and why these chemicals make it such a challenge to study and find things out. If I think of what I know very little. It's still such a field of, there's just so much to do. I only know that much. So then mechanisms of action also depend on the bioavailability. So what we have in our men that we study up north, it's a population exposed to malaria vector controls and other agricultural pesticides. They have increased testosterone, and we've discovered that the testosterone, some of that testosterone is not bioavailable. So they have it, but it's not been able to be utilized by the body. And it's probably because these other chemicals are sitting in the receptors. So, and that we did not expect to find. We also found some interesting sort of effects with the thyroid hormones. That has been published, so the work is out there. And the thing about these EDCs is they not always rapidly metabolize, especially if they tend to be lipophilic. So us as women have more fatty stores, so they like to store up in our bodies a little bit more than they do in the men. But so that's why we are sort of the ones that are quite vulnerable. So a lot of these EDCs have similar characteristics. They're highly persistent and stable. They resist biodegradation. They bioaccumulate in the fat tissue. They have additive and synergistic effects, and they very often bioaccumulate. Well, they do bioaccumulate up the food chain, which makes them really not really nice to be exposed to. And one of the problems that you have about identifying these chemicals, and people will say, yes, but you know, they're at low levels, they're not going to do anything. When you test for chemicals, when anyone manufactures a chemical and tests it, they test for three things: carcinogenicity, mutagenicity, and teratogenicity. So therefore, they are giving a high dose because they're wanting to follow the dose makes the poison. But with EDCs, it's not the case. It's usually this low chronic exposure over a period of time to more than one chemical, or the chemical itself can give you a non-monotonic dose response. So at low levels, there's no reaction. Intermediate levels, you get a reaction and you get an effect, and at high levels, it's fine again. So it's also challenging to work with that. And obviously, these sort of things were being seen in wildlife, and it's quite nice to study wildlife because you're getting an environmental picture from looking at the animals. So, as I said, these EDCs are present at low levels, and it's never a single chemical. You will always get a mixture of chemicals together. So the chemical itself might be at a no effect level. But the minute you put it with another chemical and another chemical, you'll get 1 + 1 is 5. You don't get 1 + 1 is 2. Very seldom. EDCs don't work that way, and that is why it's so difficult to test for these effects, because it's that low, consistent dose of exposure. So the chronic diseases associated, chronic exposure diseases is thyroid function, anything that will affect the brain, reproductive, cardiovascular diseases, diabetes, obesity, liver dysfunction, and cancer. And all of them can have implications as far as this is concerned. So you've heard me talk about critical windows of development and the onset of disease. So we are seeing a lot of diseases presenting in adulthood, and they're hormone-related diseases, and this can often be as a result of exposures at neonatal stage, infancy, puberty to adulthood. So you need to be cognizant of these sensitive windows of development, because especially in neonates, fetal development, you can get irreversible effects occurring. These effects will manifest later on in life, and they call it adult onset of disease, and they could predispose the adult to a number of other chronic diseases. And then, of course, you get the transgenerational effect. So the first generation does not have to be directly affected. It can be that the second generation shows effects as opposed to the first generation. or the second generation's effects are more pronounced. And we saw that in rat studies that we did with non-alphenol, that the second generation who were not exposed, they were the children of the first generation, actually had worse defects than the parent generation. So that is also something that we need to be cognizant of. So this is just a nice little diagram with the different stages of development here and what is developing and what is critical at various stages. But I'm sure you'll get access to the presentation. This is in a publication with this reference. It's a publication by UNEP and the World Health Organization. They did a state of the science of endocrine disrupting chemicals in 2012. It's also on the WHO website, and it actually is quite a nice publication. They also have a summary, which is very useful if you want to just do a quick search. And one of the, obviously for me, I come from the Department of Urology, and the male is very important to me. And he's, as I always say to everyone, he's more than just a sperm. I'm not in the reproductive making babies. I want to look after my men. So there was a guy by the name of Niels Skakebeek. He is in Copenhagen at the Rigs Hospital in the genetic and growth department. And he's been studying endocrine disruptors for quite a long time because they also have an infertility issue in the men there. And he was having a look at various factors that affected the fetal development. And he found that lifestyle factors played a role, environmental exposures played a role, as well as some of your genetic defects and intrauterine growth disorders. But basically what happened is you started getting what he called testicular dysgenesis. So you had decreased Leydig cell function and decreased Sertoli cell function, and both of those are very important in spermatogenesis and for spermatogenesis to occur, because your Sertoli cell nurses the sperm, and obviously your Leydig cell function is part of your hormone control. And he started seeing these kind of effects: cryptorchidism, hyperspadias, shortened adogenital distance, carcinoma in situ. And we actually saw, when we did the study at Ritvlei Dam and we got eland, and when we went down to histological level, we could actually see two different types of cancers developing in this eland's testes. So with that, we actually took a scanner up with us to our study area up in Limpopo. In fact, my colleague, Dr. Mutani, who's sitting here, was one of the doctors that came up with us and helped us examine the men. And particularly in this last group, which we knew they'd been exposed to DDT over a number of years, I think about almost 40% of the men showed microcalcifications in their testes on the scans. So, and that is a precursor to testicular cancer. So it's showing that something is going on in these guys. So and I mean, they are exposed to multiple, not just the agricultural pesticides, but yeah. So it is an associated endpoint. The women are not left out of this whole scenario, but it is more difficult to assess their global trends, because today many females they delay childbearing, and they have their children later on in life, leading to more increased incidence of the need for assisted reproductive techniques. But there are indicators that have shown that it is on the decrease, and the environmental exposures to the fetus and the mother and the father can contribute to this. As I say, my focal area is actually men, so I'm not concentrating on the female. My colleague, Professor Borman's actually looking at a cohort of children from birth, I think it's now the kids are 6 or 7 years old now, going on 5, 6. Some of them are a bit older, that she's followed from birth, and she'll follow through to puberty. So what sort of disorders are we looking at? Aneuploidy, altered cycles, low fecundity, usually as a result of fetal or neonatal exposure, endometriosis, fibroids, miscarriages, growth restriction, that's all sort of on the increase these days, also due to fetal and neonatal exposure, and then obviously cancer, which covers from fetus through to adult. And then the big thing now is the metabolic endocrine disruptors, which are called obesogens. It sort of started being sort of spoken about around about 2002. And in 2006, they coined the term obesogens because they were finding that exposure to these chemicals or mixtures of these chemicals was resulting in obesity in lab studies with rats. And so they started then also looking at human populations and the obesity trend there. In Europe, they did a study. It was run by Professor Juliet Legler. She's going to be at my conference this year. She ran the Obelix project, which was looking also at a cohort of children through, I think from about 5 through to puberty, and the incidence of obesity there. And then in 2015, they decided that these chemicals are going to be called metabolic disrupting chemicals. So now you have EDCs and MDCs. So we're going to have a million acronyms one of these days, and then NDCs and whatever, but basically they all alter the hormone system. So it's becoming a hot topic these days. And then thyroid EDCs, also, which groups they're from and what sort of target actions they have. It's quite considerable, but I'm going to highlight phthalates here and your bisphenols as well. Obviously, neurological issues are development, behavioral, learning. Fetal PCB exposure has led to delayed motor movement, and also autism seems to be also on the increase now. As I said, the most vulnerable are the mothers, nursing mothers, fetuses, and babies. And the lifetime exposure of the mother will determine the level of exposure of the breastfed infant. And unborn children and infants that are not able to process chemical compounds in the same way as we do are very vulnerable. So you'll find that if the mother breastfeeds and it's her first child, the levels of these chemicals in her body, in the child's body, is often higher than those of the mother, and you'd kind of half expect it to be toxic. But for some reason, it's not at the toxic levels, but it has caused effects. So EDCs in the healthcare space, I think for us it's quite important. We actually at a government hospital, so one has to also bring budget into account there, but I think the idea is to make everyone who is involved in the healthcare sector aware that these things are present and can cause effects. There are some scientists and healthcare professionals and advocacy groups that are concerned about the potential health risks, especially the pharmaceuticals, medical devices, protective clothing. When we first started out, the only gloves available were latex gloves and PVC containing gloves. So I actually did my experiments without any gloves. We now use nitrile gloves, which is much better. You have a lower risk of contamination. And also for you as a doctor. When you're in theatre, you're wearing these gloves, you perspire. The minute you perspire and you've got latex or PVC gloves on, you're opening yourself up to absorption. And the experiment we did with cheese and non-alphenol, the cheese went from the cling wrap into the non-alphenol 100% within 26 hours, and that was in the fridge. So you are vulnerable to exposure. Cleaning products, I don't know if you all know of the substance or the compound triclosan, these waterless disinfectants all contain triclosan. Triclosan is an endocrine disruptor, it's estrogenic, so rather walk around with maybe dirty hands. I don't know. But think about it before you use it too often, or think about it before you let your children use it. Disinfection products and also building materials contain these sort of EDCs. So in the healthcare space, I think it really started historically back when diethylstilbestrol was used in the 1950s and 60s to prevent miscarriages. And it was seen to cause adverse effects in daughters of women who had taken it during pregnancy to prevent miscarriage. And there were increased risks of reproductive tract abnormalities, breast and ovarian cancer, which we still see today. It was banned in the 1970s, but yeah, as I say, we still see the effects. Our current worries now are obviously our phthalates, and there's a number, and they seem to also be growing. And then one's also got to remember that you've got the parent compound, but these parent compounds also break down, excuse me, break down under certain, like everything, most things break down, and you get metabolites developing, and their metabolites are also possibly EDCs, and maybe even worse than the parent compound. And they use phthalates as plasticizers because it softens the plastics. And if you think of your drip bags, you want it to be nice and soft. Gone are the days of using bottles. And also it depends what's in the bag as well, whether it's going to leach out into the solvent or the solution in the drip bag. That's important to know as well. And is it heated? If you've got a PVC bag and you heat it, it's like if you put something in plastic in the microwave and the plastic's not good quality plastic or the right plastic, it'll leach out into the food when you heat it. It's the same with the drip bags that are made of plastics that aren't right. So they've seen associations with insulin resistant, decreased levels of sex hormone, reproductive system. And again, I want to just stress that here the infants and the children are especially vulnerable, especially in your neonatal units, because those children are not there for an hour or two. They're usually there for a considerable length of time, and they are exposed. I'll give you some information about that now. Bisphenol A is used in PVC, also in tubing and hemodialyzers and incubators, etc. It's been found in urine, plasma, and breast milk, and it's been shown to be associated with secondary sex changes, neurological behavioral alterations, and immune disorders. Then phthalates, I went and I had a good search to see where I could pick up what they found and who's done studies on it. Hugh et al. In 2005 already looked at DEHP metabolites in urine and related them to a number of DEHP containing medical devices. Rose et al. In 2012 looked at neonates receiving lipid-based infusates through PVC infusion lines, and they received a dose of DEHP exceeding the lower limit of the total daily intake set by the European Union for DEHP of 20 to 48 micrograms per kilogram per day, and some of it was up to 16 times higher than that dose. medical interventions had urinary concentrations 1 order of magnitude above the general population. And then infants requiring nasogastric and respiratory tubes also had higher concentration than those babies not requiring it. I think the thing that shocked me was the 6 hours. I think I got a bit upset about that, because that's a very short period of time into a very tiny little body. Janae found that not all DEHP-free devices are in practice DEHP-free. We found this with the water bottles. We did a study with the PET bottles, all the bottles, water bottles that you see, if you turn them underneath, they'll have a number 1. That means the plastic that the bottle is made of is polyethylene tetrathalate, and it's not supposed to contain phthalates, but it does, not a large amount, but it does, and it contains BPA as well, which it's not supposed to contain, which is why you should not reuse those bottles. You should use them once and recycle them. Do not heat them, because the plasticizers will leach out. And those chemicals land up in the manufacturing process. So if the water that they're using in the manufacturing process contains these chemicals, it's going to get into the plastic. It's not deliberately put there. So that's why people are quite sensitive about when you say that it's free and you find it. DEHP is used in smaller quantities, as Janine said, above the thresholds of contamination of 0.1% per weight. And in this study of Janae, 2 of 9 tested medical devices showed that they were truly DEHP free. And the manufacturers really need to verify the purity of the raw materials for all plastics. And I actually read in the South African plastics guidelines that the manufacturers are supposed to list the plastics that they are using, even if the combinations, because some of the combinations of plastics don't work together, which is when you also get leaching. So phthalates detected in healthcare studies, I think we need to pay caution to this, especially what's in the solutions that are inside the bags. Are they heated? Because it could release the DEHP. And and how long are the patients exposed to these devices? And just sort of, I think, be aware, because you can get an accumulation of the substances, and we don't have any regulation in South Africa as far as this is concerned. Europe is probably the forerunner with their REACH program in getting things regulated. So I also did a search to see were there other things, and polyolefins and that sort of thing, and I came up with one article. Everyone was talking about phthalates, and there was an article from 2002 that looked at the leaching of diethyl hexate phthalate from polyvinyl chloride bags into an intravenous etoposide solution. And their objective was to compare the release of DEHP from PVC from different manufacturers' PVC bags. And the conclusion was to minimize patient exposure to DEHP. The solution should ideally be stored in glass or polyolefin containers. That was the first mention I could find of a polyolefin along the line. So that brings us to where we are at currently. What are polyolefins? It means, the word polyolefin means it's oil-like. So it comes from an oily or waxy texture that the plastics have on your drip bags. And they do contain polyethylene. Now you get different plastics, and polyethylene is a better plastic than PVC. We can use it in our lab without tests, without getting contaminants. And you get low-density polyethylene, which you find in shrink-fill carrier bags and heavy-duty refuse bags today. The linear low-density polyethylenes and the high-density polyethylenes and polypropylenes, and I think they all contain variations of your polyolefins in as well. So that is just to give you a rundown of what we can find as plastics. And then why don't we register or regulate these compounds in the healthcare space? Well, the EU medical device legislation, they have existing directives on medical devices, and you need to label, and it needs to be classified as a carcinogen, mutagen, or toxic to reproduction. Toxic to reproduction actually also means it's probably endocrine, well, it is endocrine strip. So, and it must be labeled. And if they are going to use these products or compounds in the product, they have to justify as to why, and it should not be used on neonates or children, pregnant and nursing women. They're wanting to look at safer alternatives, and the fact that phthalates in toys has been banned since, for infants up to the age of 3, tells you that it is an important chemical to consider when one is dealing with children. There are some European countries that have taken action. France banned DEHP in tubing in 2015, and they're going to follow on with DBP and BBP. In fact, the other day it was a matter of 24 hours and they banned BPA. Denmark supports the phasing out of phthalates in medical devices and is promoting partnerships between industry and authorities and experts. And then what I was quite surprised to see and quite glad to see that several hospitals in Europe have implemented practices to reduce exposure. So the Austrian Vienna hospitals, their neonatal care units are PVC free. Stockholm's Sweden, the Karolinska Hospital is completely PVC free, and they phased out PVC and phthalates in 1997 already. And so other European countries are following suit. As a health professional, how can we, as health professionals, change processes and legislation to limit EDC exposure? I think we need to make our voices heard. We need to focus on limiting our exposures that can be to the benefit of your patients and improve your patients' health. You need to communicate with your colleagues and management about creating an EDC-free healthcare space. And also have self-awareness and investigate using the alternative products yourself. And hopefully this will lead to healthier hospitals and people and the planet. How can you yourself personally limit your exposures? Eat food produced without pesticide, certified organic when possible. And that can sometimes be a challenge. I always say you have this beautiful agricultural area and you've got this river running through it, and Farmer Joe up the road uses pesticides like mad and anything that he can that's chemically based, and here you are trying to do the right thing and farm organically, and the river runs right past your farm. Everything that's run off from his crops have gone into the river, and you irrigate your crops with that water. You actually need to test that water before you irrigate the crops, or otherwise make sure that you test your fruits. The Europeans are quite strict, so on taking imports with levels of agricultural pesticides, so they have to be, any fruit that we export gets tested for pesticide levels. But unfortunately, the fruit and veg that we buy, please wash them first, because there are pesticide residues on our fruit and veg. When in the garden and in the house, particularly weed killers and those sort of things, I've discovered vinegar works perfectly well on weeds. And then I go and get my vinegar from Westpac, which makes artificial vinegar. I discovered the other day because I wanted a huge bottle. And I saw it said artificial vinegar, and then I read the label, and it says 0.5% acetic acid. And I thought, what? This is with the condiments, so just be careful when you're eating slop chips with vinegar on. It's probably 5% acetic acid and not real vinegar. But it does kill the weeds very well in the garden and on my bricks. It does. Minimize your use of personal care and cosmetic products containing hazardous chemicals, especially during and before pregnancy. That is quite controversial. Sanax, actually, if you have a look, I shouldn't use brand names, should I? Oops. But if you read on their bottles, they have products that actually state that they are free of certain chemicals. And if you go to the shampoo section, there's a brand that also says they are free of chemicals. So start reading the labels. I think that's our biggest thing as South Africans. We're lazy to read labels. We want everything big. Well, I need it big because I can't see. But yeah. And keep rooms well aired and vacuum clean and dust regularly. The reason I say this is because if you have dust buildup and sand buildup, it's a bit like the microplastics. The chemicals go and sit on those dust particles, like they sit on the microplastics, and then you inhale it and you are exposed in that way. So, should we be concerned? Today still, because it's still quite a new field, but the associations are incredibly strong, you can't say that this chemical is going to cause that directly. Because again, it's not going to follow the dose response that you want. But there are high and very strong associations with adverse effects and disease and exposures to these chemicals. And there's enough scientific literature out there to show us that this hypothesis is true. And I do believe in the precautionary principle because it's my children, my grandchildren, my grandchildren's children, my dogs, my cats, and everyone that's been exposed to it that I would like to be able to protect. We need to also make our voices heard to get legislation. The Department of, what are they now? Department of Water Affairs and Environment. But anyway, it's the water guys. They change their name every 6 months. They are looking at bringing EDC testing into the water guidelines, which we do not have at the moment. We do have trigger values for estrogen activity and androgen activity and thyroid activity, but they haven't brought it into legislation yet. And unfortunately, there's still about 67,000 chemicals plus that need to undergo testing for EDC effects, and the new chemicals are being produced every day. So why I'm saying in this statement chemicals should be tested for biological activity, because that is what we are looking at. We can go and test and see, is a chemical there? How much of the chemical is there? But we're not sure together in the mixture that it is it going to cause a biological action. So there are various ways that you can test for biological activity to give you an overall idea. We do with water samples, we test for estrogen activity, androgen activity, using specific assays. And then they're also bringing in ways that we can look at non-receptor mediated pathways that we don't have to use animal, because it's really not nice doing a lab study. I've done a number and it's never a good thing for me. And only then, if it's positive, do we look at in vivo studies. And we need to remember that we have to also look at environmental presence and effects on mixtures and epidemiological studies on people. there's a lot of knowledge gaps we need to fill. But it does seem that inert polymers leach fewer chemicals and cause less harm, and that is something like your polyolefins and your silicones. I heard a very interesting webinar on silicones the other day. They don't leach, they actually take up. So if you're using your silicone baking pans, once you've baked in it, you'll see it go sort of brown and there's like oily marks there. That's because the silicone has actually drawn the oil and the fat out of the food, which I found quite interesting actually. And then the government should support the development of safer alternatives to hazardous chemicals found in medical devices, in food packaging, anything like that. We need to start opening our mouths, and you can adopt a stricter regulation. They're trying on the chemicals, on the imported chemicals, but yeah, it's still a challenge. And this is what I got in the last 2 weeks. My professor sent it to me. She said, "Oh, you're doing a talk in 2 weeks' time." I said, "Yes, I am." So this came out in this website. You really can't see. I can't even read it. It's like reading a package insert. Yeah. But I'll give it to Janine. She can pass it around. But the title was Phthalates Everywhere. Phthalates are widely used in everyday products as well as healthcare devices and consumables. Exposure to phthalates has important health implications, and exposure risk can be minimized by phasing out phthalate-containing devices and consumables, substituting it with safer alternatives, developing an effective procurement plan to phase out the harmful devices and consumables that can lead to cost savings in the long term. And there was actually a study that was done by it was a whole group of EDC experts in Europe and America, and they did an economic study on what the impact is, and it was quite frightening to see the economic impact. I think we should rather try and save our planet. I just want to say thank you very much. Thank you for listening to me for so long. All of this work that I do, we're a team, and I couldn't do it without them. And we're all passionate about what we do, and I just want to thank Janine. She came to my office, would not leave until she saw me, but she actually has given me a great gift to be able to speak to you. Thank you.